Okay. 5.5. Ben. Okay, read along with me, guys, because this is really important. This kind of brings you back to when we did the probabilities with your binomial distributions. So it said in section 4.2, you learned how to find binomial probabilities. Remember we made the chart and we said how many things could happen, 0, 1, 2, 3, 4, 5, and we did your binomial probability thing and you made a table. And then we said if it's what happens if it's less than 2, greater than 4, we used your table. We added them up. Binomial probabilities. For instance, a surgical procedure had an 85% chance of being successful and a doctor performs surgery on 10 patients and you had to find exactly 2, greater than 4. You know, if you did up to 10, we made a chart on this, remember this? Okay, but what if the doctor performs the procedure on 150 patients and you want to find fewer than 100 surgeries? Now, we kind of took care of this when we did this. And we started this by doing these two things. We did this in 4.2. We made a little test. I'm not sure if we tested it, but we did this piece in 4.2. We found your mean. We found your standard deviation in case they didn't give us all the other information. So because we're using the same type of process with your binomial distribution, you want to have an approach that's a little bit easier to deal with. So a better approach to finding how it approximates a normal curve, you want it to approximate a normal curve, is to use this method. So we're going to approximate your binomial distribution. Now, in order to do that, these two things have to be present. You have to do these two tests. If it doesn't pass these tests, you cannot go any further with this. Then it doesn't approximate the normal distribution. So you're going to take your n times your p, make sure that's greater than or equal to 5, and your n times your q. Now remember, they give us the p, the success. We find the q by 1 minus the p. Now, it's easier sometimes just to take the one that has the smaller probability and multiply that, because if that works, then the larger probability has to work. And then once we pass both of those tests, we're going to use this that we used at the end of 4.2. We barely touched on this at the end of 4.2, and I said we'll revisit this again. We're revisiting. So let's take a look at what this means. Remember, binomial distribution, binomial probability means there's two things that can happen, a success and a failure. It happens a fixed amount of times, 4 things. Probability doesn't change, fixed amount of times, success and failure, and your random variable covers all of them. So this will say in example 1, if you look at the bottom of page 259, that might be a good graph to look through. You'll notice that it approaches a normal curve as n increases. At the bottom of the page, I don't have that on my thing up here, but if you kind of look at the bottom of 259, you can see when n is 4, and see when they did n times p and n times q in the first upper left-hand box, and it's not greater than 5, it doesn't make a normal curve. If you go to the right, when n is 10, and n times p is still less than 5, it still gets closer to a normal curve, but not too much. If we drop down into the lower left box, if you look at your n times p and your n times q, they're both greater than 5. Doesn't that approximate a normal curve? Right? And the same thing on the right. So if you can see that n times p, if it is greater than 5, it'll give you an approximate normal curve. So let's take a look at example 1. Example 1 wants us to determine whether we can use your normal distribution, and if so, find the mean and the standard deviation. So you say 34% of people, 0.34% of people in the United States say that they are likely to make a New Year's resolution. Binomial because they get 2 choices. Yes, they're likely to. No, they're not likely to. You randomly select 15 people. There's your N. And you ask whether he or she is likely to make a New Year's resolution. Now, we've got to pass these tests first before we can find anything. So if P is 0.34, what is Q? 0.66. It's 1 minus that, right? Good. It's 1 minus that. Now all you have to do is plug it into this formula and make sure that it will approximate a normal distribution. So 15 times 0.34 and 15 times 0.66. Now what I was saying before is, if you take the smaller one, if this one works, shouldn't the larger one work, right? If the smaller one is greater than 5, or equal to 5, the larger one has to be greater than or equal to 5. So at least go for the smaller one. So the smaller one is going to give you 5.1, which is greater than or equal to 5, and the larger one is going to give you 9.9. So therefore, this does approximate a normal distribution. So from there, we can use your two formulas. And if you did your n times p, you already have this right here. There's your n times p right there. So your mean already is 5.1. See it? You already did n times p. So it kind of is a little shortcut. Your standard deviation says take the square root of n times p times q. Well, you already have n times p. So 5.1 times 6.66, and take the square root of that. Just put it right into your calculator. And you will come out with approximately 1.83. Now, here's our rule of thumb. Generally, you're going to stay with a binomial. So you're going to have, your binomials have no decimal places. Your mean should have 1 decimal place. Now your standard deviation, they generally go 1 more. If you go to 3, if you go to 2, like 1 more than that, that's fine. Just don't cut it to 1. Stay at least 1 decimal place more. Okay, so that's all we're doing. We kind of did this at the end of 4.2, but we kind of did it quickly. And we were okay with that because they didn't really give us large numbers, and you were still putting it in your L1, L2. So we kind of threw this at you, but we didn't really have a need to do it yet. You'll kind of have more of a need now when you're sampling all these people, like 65. You know, 15, you could kind of make a chart like we did in 4.2. 65 people, I don't think you'd want to make a chart for 65. So let's take a look at the next guy. 6%. How do I write 6% as a decimal? 0.06. Not 0.6. That's 60%. So this is your P. Therefore, what's your Q? 0.94. Good. Not a lot of information to get out of this. 6% of the people say they make a New Year's resolution to exercise more. Either they exercise more or they don't. 2 choices. You randomly select 65 people. And you ask if he or she makes a resolution to exercise more. Now, in order for this to work, it has to approximate a normal curve. It has to pass these 2 tests. So go with the smaller percentage, because if the smaller percentage works, then we're good with the larger one. If it doesn't work, we're done. So 65 times 0.06. This has to be greater than or equal to 5. And when we do this, guys, it's only 3.9. It is not greater than or equal to 5. So we have to stop right there, and we say, does not approximate a normal curve. So that's the only decision we have to make right now, is does this approximate a normal curve? If it does, we can find the mean and the standard deviation. If it doesn't, we stop. We don't do anything with it. We actually just really literally stop right there. There'll be other ways when you take a different course and take a second statistics course that you learn how to deal with other things. But and some you just will not at all. But for us, we just stop right there. Good so far? Okay? All right. Let's have you try a couple. So you guys try this one. And you're going to tell me if it approximates a normal curve, and if it does, then I need the mean and the standard deviation. So Ben, what's your page?
61.61.
Okay. What's your Q? I guess I assumed you did it since you had your calculator in your hand. Oh. 0.39. Thank you. What's the N? 70. So this is binomial because we want to know if people, 61%, kept their resolution. If they kept it. They kept it yes. They didn't keep it no. Two choices. You randomly select 70 people and you ask them if they kept their resolution. So we first run through your test. So 70 times 0.39. 27 point. So this checks. We're good. Should this one work now?
Yes. 42.7.
Oops, wait. My mistake. 61. This was still 27?
No,
It's 42.
That was my mistake.
0.39 is
0.39 was 27.3. Okay. And this was 42?
27.
Thank you. Now, in this case, after we did the P, we still have to do the Q because the Q is smaller. Or just do the Q1 first. So as long as both of these check, then we do approximate a normal distribution. Notice it never says that in there.
It's always going to be 5.
The 5 is what we check. 5 is what we check. Because if you looked at those four separate graphs, as soon as their product is greater than or equal to 5, they start approximating a normal curve. So now we find your mean, which we did right here. So your mean is just n times p, which is 42.7. And your standard deviation?
4.08.
Okay, hang on 1 second. We'll just put this in there and multiply it by your 39. 4.08. Everybody get that? Your standard deviation?
What's the middle? Yeah, what's that?
This is your mean. U is equal to n times p. And we already did it right here. And then we multiply it by the q and take the square root of it. Not right? What'd you get? Let me look at
I
mine.
got 16 times 3.
Yeah, that's what root.
Oh, square root. That makes sense.
Square root. Square root. Yeah. Yeah. Your standard deviation should be usually a little smaller. Everybody okay with this? All right. Real fast, I want you to do page 265, 1 through 7, odds. No, we're just going to go. Okay, so you're basically just walking through making sure your n times p is greater than 5 and your n times q is greater than 5. If it is not, you say does not approximate a normal curve, cannot use this. So the first one, we could see, and you start to see patterns. If your n is small and one of your probabilities is small, that's the one that's obviously going to give you trouble, right? If your n is large, you usually should be pretty good, unless your probability is like a 0.05. So this one failed the test. As soon as it fails the test, and I just had to do the smaller one there, because the larger one will work if the smaller one works. But if the smaller one fails, we're kind of done in. So the smaller one failed, we cannot use. It does not approximate a normal curve. Okay? Number 3, the n is 15, but your probabilities were both a little bit higher. So we checked it, and the 35 came pretty close, but it passed the test. So we say yes, it approximates a normal curve. Now let's put this to work. A survey found 44% read every word of a credit card contract. Do you read every word or no? That's your binomial decision. You ask 10 adults if they randomly read every word of a credit card contract. And they respond yes or no. So 44% read it, 56% did not. You check it, and of your small one, because you only sampled 10, that one does not pass. Right? So far?
Yeah.
So far, so good? Okay. And the last one, oops. The last one, number 7. Okay, number 7 says, in a recent year, the American Cancer Society said that the 5-year survival rate for men, blah, 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 was 97%. That's fairly high, but remember, on the flip side of that, 3% is a really small number. So they randomly selected 10 men. So the 10 times the 0.03 is not going to make it. The 10 times the 97 has a good chance, but the 10 times the 0.03 didn't make it. This does not approximate a normal curve. So you say can't use it. And for our purposes, we stop right there. We say, done, can't do it, and we move on. Done. Okay? So that about wraps